All right, for the warm-up, the important piece here that we want to make sure we focus on is that word right there, right? Parallelogram. The figure is a parallelogram. By the way, let me point this out because I think there's a test or a quiz question coming up. Let's say that I told you you had parallelogram A, B, C, D. If you have that, A, B, C, D, it has to go in order around. That's the way we label it, because this also helps us match sides, right? AB and CD, those are the sides across from one another. And in a parallelogram, we know that they're parallel, but they're also congruent. So that's how I would set up the value for x. And then you can just solve this. Bring the 6 over, bring the 2x over. And we get x equals 10. And then for y, we need to take the idea that in a parallelogram, consecutive angles are supplementary. And the reason why is because these two lines are parallel, and here's a transversal. These are consecutive interior angles, which means 75 plus 3y has to, 75 has to equal 3y plus 15. So if I subtract 15, divide by 3, oh, did I do that right? I think so. Yeah, so we got to be careful on our answer. Oh, no, I did it wrong. Holy cow. Whoa. I'm sorry. I didn't do at all what I said. I'm going to blame that on too many screens up at one time. They are supplementary. Wow. Glad you guys here to correct my mistakes. If I add this over, we end up getting 90 plus 3y equals 180. And then you subtract 90, divide by 3. I accidentally set them equal to each other, and I was looking in the chat to see if anybody did that as I was writing, and it didn't work. So consecutive angles are supplementary. They have to add to 180. Make sure you don't do what I just did. Okay, here's what we got. Little quote for today. Injustice anywhere is a threat to justice everywhere, by Martin Luther King. We're going to start off with a little group activity, and I'm going to throw this in the chat as soon as I can clear my screen and find the link. What you're going to do is you're going to be put in a group. I got to make sure it's the right one. Okay. So you're going to be thrown into a breakout room, and we're going to have about 3 people in the room. Our goal today is to learn about rhombuses, rectangles, and squares. And what I'm going to do is I'm going to have you go to a link that looks like this. And your job is, if you're in breakout room 1, then you're going to put your names so I know who's participating. And then you're just going to type your properties. Now, what I would like is I'd like you to talk through, okay, rectangle. What's everything you know about a rectangle? Can you throw on here? What's everything you know about a rhombus and a square? And even if you think it's right or you're guessing, put it down, right? I just want to see what we have. And so I've got 6 groups. Whatever breakout room you're in, please go to that group and then add your name. And everybody should have editing rights to this. So it should work out just fine. I'm going to put the link in the chat. So why don't you open that up right now? And then I'll create the breakout rooms. So once you have this up, go to your breakout room And we're going to go about 5 minutes on this. Okay, so thank you for doing that little activity. It's just kind of a nice way to see where your prior knowledge is. I'm going to just note a couple of things that I liked. And looking at this, I noticed a lot. You guys have a lot of prior knowledge about rectangle, rhombus, and squares. So our goal today then is to take that and build upon it, and we'll keep going and go further into these properties. One of the things I do want to mention is we have to be careful with the word all, because I think I know this is just prior knowledge, so we're not. I just want to make sure we're aware of the word all, and I had mentioned that on a couple of pieces here. So, one I want to point out one that I really like here for a rhombus. This student said a rhombus can be made up into 4 right triangles, and actually they're 4 congruent right triangles, or 2 obtuse triangles. And we're going to talk about that a little bit today. So that one is a really nice observation that I noticed. I like this one here. Opposite sides are both parallel and congruent. So we have to be careful. So here the word all is appropriate because all sides are equal. You have to be careful. I noticed this on 3 separate occasions. Some students said all sides are parallel. We have to be careful with the word all. All right, I understand what you mean, but all sides would refer to 4 sets of lines that are parallel, and that can't make a square then. So we would have to say opposite sides are parallel. So, all right. That is our goal today, is we're going to jump right into 8.4. So if you want to title your notes today, 8.4 rhombus, rectangles, and squares. Don't worry about the learning target here. So we have to really focus on how we define these words. Let's start with a rectangle. Right? When you said a rectangle, a lot of people said it had 4 congruent angles. Well, we can go a little more specific than 4 congruent angles. We can say specifically it's a parallelogram with 4 right angles. And if you don't like this part, I actually might, I don't know if I love the way that that was written. Let's do this. I like that better. And let's spell definition right. Now notice how we said this. It's a parallelogram. So when you read this and you see the word parallelogram, all of the things that we learned last week about parallelograms are true. So opposite sides are congruent, opposite angles are congruent, diagonals bisect, one side is parallel and congruent. Consecutive angles are supplementary, opposite sides are parallel. All of those things are true, but then what makes a rectangle more specific than a parallelogram is it's a parallelogram with 4 right angles. So don't overlook this word parallelogram. Okay, now we have a corollary, which is just basically kind of an extension of the definition. A quadrilateral is a rectangle if and only if it has 4 right angles. You don't have to write this down. I do want to point out this word if and only if. A lot of times in math, we look for symbols to abbreviate things. So they're going to rewrite this as IFF. I know it looks weird. It's not if, it stands for if and only if. So that's just saying that the only way it can be a rectangle is if it has 4 right angles. Because if we flip that around, if a quadrilateral has 4 right angles, then it has to be a rectangle. So you don't really need to write that part down. But what else is true? Definitely write this one down. I don't really care about the theorem number. This is just the 13th theorem in chapter 8. That's why it's 8.3. But a parallelogram is a rectangle if and only if, that's the if and only if abbreviation right there, if its diagonals are congruent. So the full diagonal is congruent, but wait a minute, if it's a parallelogram, that means the diagonals are bisected automatically. So in that case, each one of these bisected pieces would be congruent. So what do we know? We know that a rectangle is a parallelogram with 4 right angles. We also know that a rectangle is a parallelogram if the diagonals are congruent. So if you know you have a parallelogram and your diagonals are congruent, then you can also conclude it has 4 right angles because it's a rectangle. And I will just point out, you want to make sure you take really good notes today because we're going to look at properties of rectangles, rhombuses, and then squares. And all of those, rectangle, rhombus, and square, are all parallelograms. So all of the properties we learned last week are true for every single rectangle, rhombus, and square. Okay. So let's look at the rhombus. What is the definition of a rhombus? And let me know if I'm going too fast. Just throw it in the chat. I can slow down and give you more time to write. Just let me know. A rhombus is a parallelogram with 4 congruent sides. So all those properties of a parallelogram are true. Diagonals bisect, opposite sides are congruent, opposite sides are parallel, consecutive angles are supplementary, opposite angles are congruent. But now we're saying if you know that all 4 sides are congruent and it's a parallelogram, then it's a rhombus. So a corollary to the rhombus definition is a quadrilateral is a rhombus if and only if all 4 sides are congruent. Actually, I don't want that picture yet. So I don't know if some students choose not to write the corollary down because it's basically restating the definition. It's just the if and only if implies that the original statement and its converse are both true. And we didn't really get into the idea of a converse too heavily this year. So, all right, the next one is the one that somebody actually already brought up. Notice, before I even show you the theorem right here, if I have diagonals that are perpendicular, okay, now notice this is a right angle. And if I put the 90-degree angle over on this side, or on this side, or on this side, and I believe we talked about this in first trimester, if it's 90 degrees here, vertical angles makes this 90 degrees, linear pairs makes this angle 90, and same reason here. So all 4 of these are 90-degree angles, which actually makes 4 right triangles. And that's what the one person had mentioned in our group work today. So theorem 8.11, a parallelogram is a rhombus if and only if its diagonals are perpendicular. Right? So if you know that you have perpendicular diagonals, then it's a rhombus. It has to be a parallelogram And if a parallelogram has perpendicular diagonals, then it's a rhombus, and vice versa. Now, there is something really special with these diagonals. Not only are they perpendicular, but they actually bisect. Parallelogram is a rhombus if the diagonals bisect the opposite angles. So notice those pieces are congruent and so are those. And we could put the same thing down here. I might draw these all the same color. So this diagonal bisects the two opposite angles. And then the other diagonal bisects the angles as well. Which, if you just note, we know it's a rhombus then. So this side is congruent to this side, and all of these triangles then are congruent by side or angle, side, angle. I put my congruent markings in here because it's a rhombus. All four of these triangles will be congruent by angle, side. Okay. So there's kind of a lot more about a rhombus than a rectangle, but a rhombus is a parallelogram with four sides. We also know that the diagonals are perpendicular, and we also know that those diagonals bisect the opposite angles. So what about a square? Well, by definition, and a lot of people had this, a square is actually the byproduct of both a rectangle and a rhombus. So if a parallelogram is a rectangle, meaning it has four right angles, and if it's a rhombus, meaning it has four congruent sides, then it is a square. Now, we are not going to get too heavy into the proof side of all this. I'm going to put here, if I have four congruent sides, that means it's a rhombus, right? Four congruent sides is a rhombus. If I have four congruent angles, then it's a rectangle. Correct. A rhombus does not have four right angles. Because if a rhombus, and that's a great question to bring up right now. What if a rhombus has four right angles? Well, then we don't call it a rhombus because it's a rectangle as well. If it's both a rhombus and a rectangle, then we call it a square. So that's kind of that process of thinking is we say, okay, if we officially wanted to prove this, we should first prove that a shape is a parallelogram using any of the methods that we learned last week. And once we show it's a parallelogram, then if I can show that it has four sides that are congruent, then we can conclude it's a rhombus. But if it also has four right angles, then we can conclude it's for sure a rectangle. And if it's both a rhombus and a rectangle, that makes it a square. Okay, so here is the square corollary. I would write this one down. I think this one is important for us to get down and kind of justify. So how do we know that it is a square? If a quadrilateral is a square, well, I should say a quadrilateral is a square if and only if it is both a rhombus and a rectangle. And if we're justifying our work, we need to actually show that it is both a rectangle and a rhombus. So here's my thought on this, is if you really understand what a rhombus is and all of its properties, and you understand what a rectangle is and all of its properties, then anything that shares both of those is a square. That's how we treat that. Okay. I don't want you to write this next slide. I'm a visual learner, and if I can frame things in my mind visually, that helps me with properties and just kind of the way things flow. If you like this, you can always reopen it back up when I post the notes. But here's a Venn diagram just to kind of give you guys a visualization of types of parallelograms. So remember what a Venn diagram is. Anything that is inside the red shape is a parallelogram. Okay? And then what are parallelograms? We wrote all of this stuff down before. That's why I don't want to take time to write this. But if it's a four-sided shape, then opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect. And one pair of sides must be both congruent and parallel. So all of those are true for anything that's a parallelogram. Well, if I get more specific, a rhombus, or this is plural for rhombi, is just a parallelogram with an extra special property, four congruent sides. Right? And a rectangle is a parallelogram. That's why it's inside of the red shape. It is a parallelogram with four congruent angles. Now, there are other properties for a rhombus and a rectangle, and those are on our other sheet. I just didn't have space to write them. But then if a rhombus and a rectangle share similar properties, or I should say a parallelogram shares the property of a rhombus and a rectangle, then it's a square. So that's how my brain works, is this is a visual piece that just pops in my head, and it kind of helps me justify things. If I say something's a rhombus, I have to first say it's a parallelogram. And actually, outside of here, if I counted this whole white screen as another piece, outside of here is just quadrilaterals. Because officially, a parallelogram has to be a four-sided shape. So anything that's on the whole screen is officially a quadrilateral, and then more specific is a parallelogram, and more specific is a rhombus and a rectangle, and even more specific is a square. Right? All right. So let's look at a couple of properties and problems. What I would like you guys to do, we're going to do this one together, but I want you to see if you can draw the picture, because you'll notice there is no picture given. And that's one of the challenges to problems like this, is you should be able to draw a picture of this. So let's say the diagonals of a rhombus are 6 inches and 8 inches. What is the perimeter of the rhombus? So we'll work through this together, but draw a picture here. All right, I'm actually going to add one extra piece. Let's say that this was rhombus A, B, C, D. And I asked you to draw a picture of a rhombus. Well, I'm going to cheat by using my smartboard. So what do we have? If I say it's A, B, C, D, A, B, C, D. I just want to make sure you're aware when it's written that way, it has to go in order. You couldn't do A, B, C, D. You can't flip these around, otherwise the side lengths don't match up. Now that's not important for this specific problem, but what is important is the fact that they give us the diagonals. So I need to draw in the two diagonals, one from A to C and one from B to D. Now, here's the way my brain works when I see a problem like this. I see the fact that it's a rhombus. If it's a rhombus, it's a parallelogram. So that means diagonals bisect each other. So those diagonals are bisected, but it's a rhombus, which means they bisect each other in a special way, in a 90-degree or a perpendicular. So that means that, okay, if one of my diagonals is 6, let's call that AC because that's the shorter one. That means that AC being 6 was actually cut in half, right? So that piece is 3 and that piece is 3. And then the other diagonal, we'll call this BD, was 8 and that was cut in half. Our job now is to find the perimeter. What is the distance around? Well, wait a minute, it's a rhombus. So I do know that all 4 sides are equal. All right, which means if you look at this, I've got 4 congruent right triangles. So I only need to find one side. If you would like, you definitely don't need to do this. But what do I have right here for one triangle? I've got a 3, 4, and we are going to assume that you know Pythagorean triple. 3, 4, 5. Right? Now, if you didn't notice that, you could do this work. Right? And dot, dot, dot. If you do it, you end up with the square root of 25, which is 5. So this is a triple, which means it's a rhombus. So all 4 sides are congruent. And my final answer is the perimeter of ABCD is equal to 5 plus 5 plus 5 plus 5, or 20 inches. Okay. I had one question in the chat here, quick, I'll bring up. It's more of I can answer this visually pretty quick. It doesn't have to do with this problem. So I'm just going to, let's say that I have a rhombus. Now, I think this is going to work. Notice a rhombus can be, well, it's not going to work perfectly with this one. But as long as my sides are congruent on a rhombus, I could flatten them out quite a bit like this. So if I drew this perfectly, and again, this explanation doesn't have to do anything with the problem we just talked about. But if I drew this rhombus, so I have 4 congruent sides, notice how the angles opposite of each other, they're still equal, but they don't have to be 90 degrees. Because if angles across from each other were 90, then that would basically turn this shape into a 4-sided shape with 90 degrees. It would turn it into a square. So when opposite angles are not 90 in a rhombus, then it's only a rhombus. When they are 90 degrees, then it turns into a special shape, which is a square. I'm not sure if that directly answered the question, but hopefully. Okay. I don't know if I want you to write this one down. Let's do this. We're going to come back to it. I definitely want to get to this problem, and I want to make sure we have enough time for it. Now, you don't have to write all of this down because the top part is they tell us it's a rhombus. The diagonals are A, B, C, D of the rhombus A, B, C, D are given. They intersect at point E. And then they tell us BAC is 53 degrees. So we have that in there. And DE is equal to 8. So just draw the picture here, and then we're going to answer all of these questions based off of the given information. And I don't want you to work ahead because this can be a little tricky. So before I even look at answering any of these questions that they're asking, I'll show you how I approach this problem. And it's all just based off of the information that I know. So as I'm drawing my picture, they tell me that it's a rhombus. Okay, well right there, I'm going to add 4 congruent sides, because that's definition of a rhombus. I know I have 4 congruent sides. But then I also know a couple other things. I know that the diagonals are perpendicular. So I know that that has to be 90. If I really want to, I could put 90 degrees at the other 3 angles, but I'm just going to leave it like that. But a rhombus is a parallelogram. So I know that opposite, I'll use a different color here. Because it's a parallelogram, I know that the opposite, the diagonals are bisected. So AE is congruent to EC, and DE is congruent to BE. And you could look at right here, proves by HL, hypotenuse, and I actually know both legs, but this triangle ABE is congruent to all of the other triangles by hypotenuse leg, or even side angle side, or side side side. There's a lot of different reasons. All right, so now let's add some important things. If I know that DE is 8, well then I know BE is equal to 8, because those are congruent. And if I follow a Z, this Z right here, I'm not going to highlight it because it'll get really messy, but this 53 degrees is the same as this 53 degrees. And then wait a minute. If this is 53 degrees and this is 90, we can find this angle here very quickly, right? Because that's just a triangle. They all have to add up to 180. So if I take 180 minus 90, 90 degrees is left between these two. And 90 degrees minus 53 gives me 37. Which, if I go the Z the other direction, because it's a parallelogram, so opposite sides are parallel, so this Z makes this angle right here 37 degrees. And then you could make the same conclusions for the other angles because they're all congruent. So you could piece in this angle is 53. This is 37 because the diagonals bisect. Right? So we know a lot of information. Actually, I know almost everything. I know everything except for the length of the rhombus, the length of the side, and the length of AE. So now, I hope you're thinking, okay, well, that was a lot. I didn't even answer a single question yet. But now let's actually just kind of go through and look at, well, all right, now that I know all this information, what are they asking me? So find the measure of DAC. DAC. Oh, that was 53 degrees because diagonals bisect. Find the measure of angle AED. AED, that's the angle formed at the diagonal. Well, that's 90 degrees because diagonals are perpendicular in a rhombus. Find the measure of ADC. Well, that's the big angle here. And because we found this angle to be 37 and this was 37, these two angles are 37. So if I add up the big angle, ADC, 37 and 37 is 60, 74. Okay. And then now we're getting to length. Find the length of the diagonal DB. Well, it's a perpendicular bisector. cut in half. So if this was 8, DE was 8. 8 plus 8 gives me 16. Now comes the fun part. I'm going to do these in a separate color. I need to find the length of AE. That's this length in red. Well, the only way to do this is to take one of these triangles. Let's take this red triangle here and just rewrite it. And I've got 53 degrees. I know this side length is 8, and I want to find this length right here. Now I'll say this, I could use the 37 degrees as well. I want to keep it simple. So I'm going to stick with the 53 degrees that they gave me. Well, hopefully you're having fond memories of how we do this problem. I have the opposite side and the adjacent. Yes, SOHCAHTOA is going to make its return. Right? So we have to be able to know how to do SOHCAHTOA to find side lengths. So if I have the opposite and the adjacent, I've got tangent. Tangent of the reference angle 53 degrees is equal to the ratio of the opposite side over the adjacent. And then we can just cross multiply and solve. So however you want to do it, some people say, ooh, the x is in the bottom. I'm just going to switch the place of the x in the tangent and do 8 divided by tangent of 53. Personally, that's what I like to do. If you don't like that, cross multiply and then divide. You're going to do 1 times 8 divided by tangent of 53, that was 7. And then my calculator comes to the rescue. Okay. Make sure, we haven't done this in a while. I know I'm in, oops. So I have to check my mode often because anytime I use my calculator one, it goes to radians, but we need to be in degrees because we're doing 53 degrees. So I'm going to change it to degrees, and then you guys know how to do this. 8 divided by tangent of 53. And that gives me x as 6.028 if I round to 3 decimal spots. It's really big now. There we go. Okay, so that was the length of AE. 6.028. Then they say find the length of AC. Well, AC is just double the length of AE. So all I have to do is do 2 times that, and I'll get 12.056. I just doubled it. Nothing too crazy there. Now, I do want to actually add an extra little piece in here because this is going to come up. Find the length of AB. Well, here's AB. Or actually, I could say find the length of BC. That might even be better. If I tell you to find the length of BC, well, I have this already set up. This triangle, this red triangle, is the same as all other triangles in here. So if I can find AB, AB is the same as BC. So it really doesn't matter which side I ask of you. Now you could do Pythagorean theorem because you know this is 8 and you just found AE. You could do Pythagorean theorem, but you already have everything set up here. So why not call this one Y? And now this is the hypotenuse. If I have the opposite and the hypotenuse O and H, then I'm just setting up the sine ratio. The sine of 53 is the opposite over the hypotenuse. So 8 over y. And because the y is in the bottom, we could just flip it around. Or you could just cross multiply and divide. 8 times 1 is 8. Divided by the sine of 53 degrees. So then, again, let your calculator do the work. Do 8 divided by the sine of 53. And we get 10.017, and the rounding is okay. So we're going to just leave 0.17. So now I know the length of any of these side lengths because it's a rhombus. So I could ask you to find the perimeter now, right? And all you would do is take one of these side lengths, AB or BC, whatever one you want, and times it by 4. And that would be the perimeter of this shape. So we found every single thing we needed or could find about this just from the word rhombus and the given information. Okay, so pause, if you're watching the video here, pause the video, read through this. We are going over answer A. Right now, just by knowing that opposite sides are congruent, does this information give us enough information? No. All it does is it shows that this shape is a parallelogram. Right? It shows opposite sides are congruent. Well, what we need to do is we need to check to see, are these diagonals equal in length? So if you actually took and measured the length of one diagonal and compared it to the length of the other, they would need to be the same. And then part B says you measure the diagonals of the opening. The diagonal 1 is 54.8 and the diagonal 2 is 55.3. What can you conclude about your shape? Well, we can conclude that the shape is not rectangular. I don't want to spell rectangular correctly today. There you go. And the reason why is diagonals are not congruent. Okay, but it says, what can we conclude about the shape? We know for sure shape is a parallelogram. Right? Because its opposite sides are congruent. Okay, I will let you know, little side note here, I actually used this exact theorem this summer. I was building rectangular concrete slabs in my backyard, and I needed to check that they were congruent. And I did two things. Me being a little bit of a math nerd, I checked that the diagonals were congruent, but I also checked that this was a right triangle. So I measured these lengths, and then I did Pythagorean theorem here. If I did this specific problem, my measurements were obviously different. But I did Pythagorean theorem to figure out what should that C value be and what should my diagonals be, and then I made them perfect, because if it wasn't right, then you tweak things a little bit. If you have any relatives or parents or brothers or sisters that are in the trades, ask them about the math they use. And a lot of them will talk about a 3, 4, 5 right triangle. My dad is a plumber, and he uses SOHCAHTOA. He uses 3, 4, 5 right triangles all the time to check for they call it square for 90-degree angles. But it's a really cool skill that you could use later on in life. All right, what do we have for homework tonight? We have 8.4, and I will say that the answers that are posted for 8.4 are not great. It doesn't actually justify what we need to, so I'm going to go back later today and redo these answers and then post them again. So that way you'll have better answers. But you can see the work down here is very similar to what we did in class. The only difference is we now have a rectangle or a square instead of a rhombus. And then here, the justification pieces, you have to explain why it's true. So we want to give a little more detail on these answers. That's all I have. We're done a couple minutes early. So if you want to stop by my office hours, I'm available from 1. Oh, hold on. Don't go anywhere. I actually had one more thing that I just thought of. Not a lot, a handful of people said they were having issues with their can figure it. And I think this is it. Okay, some students were like, I log in, and I hope it doesn't, and nothing shows up. This doesn't do it for me. Actually, I signed in on the wrong thing. Anyways, here's one of the quick things. If you said your can figure it did not work, okay, if it doesn't show up, one of the reasons is you have to maximize your screen. You should go through Google Chrome and then maximize it. And once it's maximized, then you can see all the quadrilateral pieces that you had to do. Okay, that's a really easy, quick fix that I think a lot of people were having issues with. If you are still having issues with Can Figure It, stop into my office hours from 1 to 2 today.